Hello. So today we are going to be looking at health of a waterway. So couple different ways that we can tell how healthy a waterway is. The first two kind of go together, temperature and dissolved oxygen. So dissolved oxygen is the amount of oxygen obviously present in that water. We need it because there's animals that breathe oxygen through their gills, so we need to have oxygen in the water. And then the next three, nitrogen, phosphorus, heavy metals, these are all different chemicals that can be in the water that can cause lots of different stuff to happen. And then next we have macroinvertebrates. We are going to talk about that later after spring break. And then we're also going to mention pH today as well. So as we're looking at the temperature of the water, we do have an increase of thermal pollution. So typically this is going to be from industry. So if you've ever been to Port Washington and Coal Dock Park, you'll notice that there are like little inlets where they actually have efferent water. That means exiting water from the power plant that is there at the coal dock. And that has increased the temperature of the water in those areas. It can cause different fish species to live there from normal. We can also have thermal pollution from urban activities. So if you have water that falls on like a road, a sidewalk, a parking lot, just like you talked or we talked about in the last notes with runoff, when that water falls on that hard surface, it is able to heat up more than water that would fall in like a pond or a lake or something like that. So once that water falls from the skies, precipitation, and it runs off, that heated up water then in turn, when it goes into the waterway that the watershed flows into, it's going to heat up that water. Part of the reason why this is really, really important is cold water can hold more oxygen than warm water. It is super, super crazy. So steam is basically the hottest water, cannot hold any oxygen. And then ice can hold oxygen for really long periods of time. That's why, like, when you have ice cubes that are foggy, they're not perfectly crystal clear. That's little oxygen bubbles that have basically come out of that really, really cold water. As water gets warmer, oxygen levels are going to decrease. And when that decreases, it causes basically fish to suffocate. And it is partially decreased because the amount of bacteria goes up. So bacteria likes a warm environment to grow. So the more bacteria that is growing in a water or in a waterway, the more oxygen that bacteria is going to take out of the water because bacteria also needs oxygen, and then it leaves less water for the fish. So human activities can increase this very, very dramatically. Couple stuff that we talked about already. One that I want to touch on is this one. So removing shoreline trees. One of the really, really important things with maintaining health of streams, rivers, all of that stuff is maintaining trees on the banks for a couple different reasons. One of them is for runoff. So as water runs down its watershed into that body of water, having trees with those nice deep roots can hold the soil on the banks so it doesn't run off into the stream. The second one is because trees provide shade. So they also cool the water whenever you have trees like going over waterways. So kind of crazy. Looking at soil erosion as well, when you remove those trees, if you look at the next one, soil erosion can cause soil particles to enter the water. And then when those soil particles enter the water, it makes the water darker. So you think about like a clear glass of water and a dirty glass of water. Which one's darker? Well, the dirty glass. So when heat goes on it, it actually heats up the water more. So one of those things that has lots of different effects. So with this as well, we have this little chart here. So we have oxygen saturation. So this is 13 ppm. And then down here, temperature in centigrade, which is just like the British way of saying Celsius, down here. Okay. And then temperature in Fahrenheit up here. So the fish tank, that is at, I think, 42, 43 degrees because trout like really, really cold water. So that means based off of that, if we look at temperature in Fahrenheit, the oxygen saturation of that tank, if it's a healthy environment, is going to be somewhere between 12 and 13%. parts per million or whatever. Okay. If that water would be low or raised to like 77, which would be somewhere a little bit higher than room temperature, you can see how much that oxygen drops, and it can be really, really bad. So that line is the maximum oxygen that water can hold at that temperature. This bottom line, this is the level at which aquatic life can no longer be supported at all. So when it's below 5 milligrams per liter, that's when nothing can live there anymore. Okay. So unsuitable for most aquatic life if it gets that low. So next, pH and acid rain. In regular bio, we did talk a bit about this and pH with sea critters and marine life. So just to reiterate again, pH scales from 0 to 14. The lower the pH, the more acidic it is. So 0 to 6.9 infinity is going to be acidic. 7 is neutral, and then 7.00000 whatever 1 to 14, that is going to be basic. Both of those fluctuations on either side of around neutral are going to be bad for anything that lives in there. One of the biggest things that we are concerned with is acid rain. So with industry, cars, different stuff like that, we get sulfur compounds, ammonia compounds, nitrogen compounds. When those go into the atmosphere, when they mix with the water that's in clouds, they can actually make different types of acid. So those acids fall and then go into a mild solution of sulfuric nitric acid that is falling in rivers, lakes, streams, going down their watershed. Part of the damage with this is that acid can actually leach nutrients from the soil. So what can happen when that acid rain goes into the soil, it basically like takes nutrients down with it. So any plants that are living at the surface cannot uptake those nutrients with their roots. So it can cause nutrient deficiencies. That is also like kind of a step effect. So if the plants have really poor nutrients, the critters that eats the plants are going to have poor nutrients, and the critters above them are going to also have poor nutrients. When acid rain falls on leaves and needles, it can leach nutrients from them as well. When acid rain combines with ozone, that waxy coating that's on the top of like leaves and pine needles and stuff like that can actually be eroded away, and it can damage the leaves of plants. It can cause toxic buildup in waterways. When we're looking at this as well, most aquatic organisms cannot survive below a pH of 5, and trout die at a pH below 6. So that's why with the water testing that Preston has to do in the fish tank, pH is one of the things that we test to make sure that it is staying more towards the alkaline side. Fish actually like the water a little bit alkaline, not necessarily neutral. Okay. So before we move on with the other ones, we do have to mention this thing called eutrophication first. So what eutrophication is it's basically too much of a good thing. So if we have lots of excess nutrients that get into the water, that can create really, really dense bacteria life. And then when we have extra bacteria in the water, that takes away oxygen from fish because the bacteria are overproducing and taking their oxygen. And then it kind of causes a cascade of a bunch of things dying. So if we look at this system here in a healthy ecosystem, we have runoff that goes into the water. We have a little bit of nitrogen and phosphorus that's going to get in there, and that's inevitable. That happens naturally as well. That nitrogen and phosphorus is used by some of these plants. These plants are going to create oxygen for the fish. They are also going to eat those plants, all that good stuff. On the other side, in a eutrophic ecosystem, we have excess runoff primarily from agriculture. So lots of fertilizers have excess nitrogen and phosphorus in it, but also from factories as well. That excess is going to feed bacteria. Bacteria take oxygen away from fish. So when these fish die, they also are going to create food for those bacteria as well. So they are going to be numbing all that stuff up. With those bacteria, the plants are like algae stuff is going to way overgrow. So we also see that the plants in the water aren't getting sunlight. So they're also going to die. And then the bacteria are going to eat them up and use more oxygen in the water. So it basically just makes a really, really poor ecosystem. So once again, another little way. So we have runoff and fertilizer leaching in. We can get algal blooms because of these excess nutrients. Bacteria use oxygen to break down that algae that's decaying, break down all the stuff, and then fish suffocate because of lack of oxygen. One other thing just to touch on as well that you will see is point pollution and non-point pollution. So basically the difference between these is point pollution can be directly traced. So the thermal pollution that's happening in Coal Dock Park in Port Washington, we can directly trace that to the coal power plant that's there. We know exactly where that thermal pollution is coming from. Non-point pollution, that's just like general runoff. So if we have an excess of fertilizer in Silver Creek, we don't necessarily know which farm field it's coming from. It's just coming from agriculture. Or if we have increased levels of salt in a river, lake, or stream, that's probably from runoff from roads when we spread salt during snow events. But we don't necessarily know exactly what road is the one that is causing the most salt. Okay. All right. Nitrogen compounds. These are really, really important, especially one day if you are ever a homeowner or have a groundwater well in your house. It is really, really important to test for nitrates. All over Wisconsin, there tends to be some issues with excess nitrates in people's drinking water. It can come from sewage that leaches into waterways, inadequate wastewater treatment plants, and improperly functioning septic systems. Nitrogen is needed for all living things, but with eutrophication, too much of it is definitely a bad thing. And manure is really, really rich in nitrate and ammonia, both of which can cause eutrophication and are specifically things that we test for in the trout tank because these things can poison fish, basically. Looking at some of these sources of nitrogen, fertilizer is one of the biggest one with improperly constructed barnyards and feedlots. So lots of the animal waste not going into a biodigester, bioreactor, anything like that, and it goes into waterways. Water with really, really high amounts of nitrogen can cause something in little babies called blue baby syndrome. This is because when nitrogen gets into your body in excess amounts, nitrates actually will attach to your red blood vessels instead of oxygen. So nitrogen attaches, oxygen doesn't, and it can cause the baby to turn blue. Really, really sad. It is very, very fatal. So one of the really common things, and one of those things they don't tell you until you have kids, is they want you to test your drinking water at home for nitrates before you have a baby, especially if you're like mixing up formula or something like that. So it's something really common that you can test for. You can get at-home test kits, or you can send it off to private labs. And in Wisconsin, if we just flip back, there are a lot of issues with nitrogen, especially like in the southern and central part of the state. And that has to do with the sandy soils that are in that area. So with our wildfire unit, we talked about the sandy soils not holding water makes these areas really fire prone. In the same turn, it also causes increase of nitrogen because with those sandy soils, water infiltrates really, really quickly into the ground and it doesn't get filtered out, and it gets into the drinking water really, really fast from farming in those areas. So looking at phosphorus compounds, also found in fertilizers, also found in detergents and municipal water systems. So these can also cause algal blooms. If you guys think about the field, let me see what direction, west of school, like behind the classroom, out the windows that way, every once in a while you'll see some like big water spraying out there. What that actually is it comes from Lakeside Canning in town. There's a water line that runs underneath the whole town that sprays basically phosphorus into that field. So it is excess from the canning process. It is detergents from them cleaning different things there, but that's where they get rid of those chemicals. And what that has done is that water should get soaked up by the plants that are in that field, in that furrow system, but not a lot of it does. It's not super efficient, and a lot of that water actually gets into Silver Creek, which, as you guys looked at in the watershed, will go into the Milwaukee River, which goes into Lake Michigan as well. So this has led a lot of local governments to actually ban phosphorus-based fertilizers, because just little tiny bits of phosphorus can make eutrophication happen really, really quickly. So if we look at this map of Wisconsin, and I forget what year this is from. I think this is from 2020, 2021. 172 lakes and streams are listed as impaired due to the amount of phosphorus that's in them. So if we look here in Sheboygan County, more in northern Sheboygan County, otherwise we're pretty good, which is pretty awesome. But if you look here in the Wisconsin River that goes into Green Bay, that whole area, this whole area is impacted, phosphorus impaired area. And then this tan, that is the watershed that feeds into that. So everybody within that watershed area is responsible for the health of the waterways that are in those red areas. Looking at this as well, the year this was taken, and once again, I forget if it was 2020 or 2021, 35 people in Wisconsin that year reported human health concerns, and dogs can actually die from blue-green algae. So if they drink the water and some of those eutrophic things, they can actually die from that, which is no bueno. So lots of stream assessment data says that thousands of streams may have excess levels of phosphorus, but to go out and test every single waterway is just not possible. All right, next one. All right, and then the last part that we're going to talk about today is heavy metals. So all living organisms require trace amounts of heavy metals. That means a little teeny tiny bit, okay? The biggest threats to us are cadmium, chromium, mercury, lead, arsenic, and antimony. Those are primarily used in infrastructure and like factories and things like that, and they can run off into the water. So looking specifically at just a couple of them, lead is very, very weird. With lead, if you look at the periodic table in lead is right next to calcium, and it acts like calcium in your body. So if you are a child and you eat lead paint, have lead exposure, there's lead in the pipes in your home or anything like that, you can get lead poisoning. So what happens is that lead will go into the bones of your body and become part of your bones. So part of this here is the lead that is stored in your bones is not necessarily harmful. But then if you eat a high amount of calcium, so like little kids are supposed to drink milk all the time, right? Because they're growing, they need to build bone tissue. What happens is the calcium that you ingest through like drinking milk, dairy products, whatever, then does like a little switcheroo and it flip-flops with the lead. So then that lead in really high amounts gets released into your bloodstream all at once. It can cause speech language behavior problems. It can cause anemia, so loss of red blood cells, reduced growth. You can have reproductive issues later in life, decreased mental ability, brain and nerve damage, really, really bad stuff. So that's something else that, like, if you have lead pipes in your home, you want to make sure that that lead is not leaching into your water, because it can be really bad for any kids that would live in that home. The next heavy metal that we do have issues with in Wisconsin is mercury. Mercury is transformed by microorganisms into a more toxic form. If you get mercury poisoning, kidney, liver damage, circulatory system failures, really, really crazy. Usually, if you get chronic poisoning, so this is poison kind of adds up over time, it is the result of typically one of two things. One, working in a factory that has a lot of mercury. Two, eating contaminated fish, because mercury is a metal that can bioaccumulate. So in regular bio, we talked about bioaccumulation of different things and biological magnification. Mercury is a chemical that can do that. And when we look at mercury, I don't have a map of Wisconsin. So when we look at mercury, lots of fish in Lake Michigan actually have increased levels of mercury, and there are actually advisories out there. So if you are a young child or if you are pregnant, they actually have advisories for certain waterways that you should not eat fish from those areas because of high levels of mercury in them. Okay. So with this, when we get metal levels in natural waters, they can change how your tissues are actually formed in your body, change your blood chemistry, can change behavior. A lot of this stuff is really, really well researched and well known for a very long period of time. So, like, all of this research was found in 1984, so over 30 years ago. Um, when we're comparing freshwater fish, um, they're going to be equally or less sensitive typically than invertebrates, plant life, but all of those things need everything else to grow. So heavy metals are a huge concern. This is what I was talking about. So this is from the DNR. This is something that they have. It's called Choose Wisely. So if you just look up on the internet, Choose Wisely, Wisconsin DNR, they have a publication where you can look up specific advisories for fish consumption. So this is our area. So Dodge, Jefferson, Walworth, Sheboygan, like this whole area here. So up here, Sheboygan Falls Dam, from that dam to Lake Michigan, there are some areas where not yet, where you should not eat a lot of the fish that are there. Like Michigan is in that. If you look in Ozaukee County, from Bridge Road of Cedar Creek Park all the way out to basically Milwaukee, you should not eat a lot of the fish that are there. So this is guidelines for mercury specifically. So on Big Elkhart Lake, if you get a fish that's over 19 inches long, so that is going to be indicative of how old it is, you should only have one meal per month with that, or don't eat it at all. So because there's a lot of mercury in Big Elkhart Lake. Guidelines for everyone for PCBs. So these are some other chemicals that we have. These areas that are in green for this other metal chemical, there are some requirements for them. So you should not eat carp of any size from the Milwaukee River or any of these areas because of those advisories. So kind of interesting, kind of unique situation that we have here in Wisconsin.